Hello, welcome to AP Environmental Science, Chapter 10 lecture. All right, well, this chapter here is on agriculture and sustainability, basically. Let's begin by talking about the central case in our chapter. The central case was about a farmer named Steve Marsh who had organic crops that he was growing. This is in Australia, by the way. What was happening? His neighbor, Mr. Baxter, was growing up what's called Roundup Ready canola. Roundup is a name of an herbicide, a weed killer. All right, it's the most commonly used weed killer on the planet. Its chemical name is glyphosate. So Roundup, glyphosate, same thing. A lot of people use it around their houses here in San Diego. People use it all over the place. All right, it's very widely used. So what was the problem Mr. Marsh was happening? Well, Mr. Baxter's genetically modified crops, their seeds were blowing into Mr. Marsh's property where he was growing organic crops. Well, genetically modified crops do not constitute being organic. They would not certify Mr. Marsh's crops if he had genetically modified crops growing there. So, because his seeds blew into his field, basically, Mr. Marsh was suing Mr. Baxter in the court. Now, this is happening in Australia, granted, so the laws are different there than they are here. I don't believe Mr. Marsh won his case. The court said, it happened by accident. It wasn't intentional. All right. So the problem was Mr. Marsh, a good deal of his land was no longer certified organic because of having those genetically modified crops present. All right. In the U.S., if this happens to you in the United States, if a farmer has genetically modified crops blow into his property in the United States, you are now liable because now you're growing seeds that are technically owned by a corporation, and you've infringed on certain laws. Basically, you weren't. So in the United States, they truly protect the corporations rather than the farmers. It's a really crazy thing here in the United States. It's very common. So in the United States, if you're a farmer and you're buying seeds from one source by the way, the company that makes these seeds, the Monsanto company, produces them. Well, they own the rights to these. So these crops are, they've patented their seeds. If their seeds blow into your property here in the United States, start growing on your property, and they find out about it, and they do genetic testing all the time to see if it happens, you are now liable, even though it blew onto your property. So the Monsanto company comes after those farmers and sues them and pretty much tries to destroy them, even though they did not do anything intentional. It's really sad. What these companies are doing, Monsanto, for example, what they're trying to do is they're trying to get the farmers to buy their seeds. And if you don't buy their seeds, they come after you if their seeds are windblown onto your property. It's loopholes in the law they take advantage, and they're so powerful they can really hurt a farmer who only has so many monetary resources to fight back. It's a very sad situation. This company, partakes in a lot of shady practices, and they go after these small farmers all the time. Let's define a few things. Undernourishment. Well, not getting enough of your daily calories. It doesn't mean you're getting all your nutrients necessarily. It just means you're not getting enough energy from your diet. Okay. Food security. Well, this has to do with being able to provide reliable food for people. Food security has changed over time. We're going to talk about that in a little bit more. It's gotten better. We've gotten better at growing things. So farming practices have increased yields. Therefore, food security worldwide has gotten better, much better. Here in the United States, we have a severe problem with overnutrition. Why am I saying the United States? Because we eat a lot of fast food. Fast food is high in calories. We generally get more calories. A lot of people in the United States do than is needed. All right. So getting too many calories, overnutrition is a common problem in the United States. People who travel the world will notice that people all around the world are generally thinner than Americans. And the American diet is not very necessarily healthy. More terms, malnutrition. Now, this is where you're not getting certain nutrients, okay? Certain nutrients, and not necessarily, doesn't mean you're not getting your calories. You might be getting your calories, but if your calories are all coming from, say, sugar, for example, or starchy food, then you're not getting the right lipids and protein. In this case, lipids, the fats that you need. All right. If you're getting a lot of your food it's coming from starch, you're not getting proteins, you're not getting vitamins and minerals that you may need. All right. Kwashiorkor, this is when you see a distended belly, a bloated belly usually it's on a child, is where you might see it. What's happening is the reason their bellies get bloated, they almost look like their belly's sticking out, like they're full of food, but they're not. Because of the lack of protein, which is kwashiorkor, because of the lack of protein in certain amino acids, their body's ability, certain osmosis regulation isn't controlled, which means water diffuses in areas where it shouldn't as a result of these proteins that are missing. So what happens is because these proteins are missing from their diet, their bellies bloat and fill with fluid, like they store water basically. So they have their bellies protrude, they stick out. They look like they're full of food, but they're not. They're swollen with water basically. Okay, generally happens in countries, in African countries, specifically when mothers are no longer breastfeeding their children, and now their children's protein diet, their protein intake is deficient, basically. Marasmus, this is pretty much like shriveling and wasting away. So it's not just protein, it's calories, it's insufficient protein and calories. All right. And literally the body shrivels away. It's like a bag of bones. You're seeing it on this child over here. Green Revolution. Well, what happened in the 1940s? Well, Norman here, he pretty much said, hey, I figured a few things out. Here's what I figured out. I figured out that due to crossbreeding and artificial selection, he figured out, well, we got some wheat. We got wheat that basically can grow, and it's very resistant to disease, and it's high yield, which means it's producing more than we normally get. So what he did is he introduced this to Mexico, and what happened? They tripled their wheat production. All right. Then they sent it over to India and Pakistan, where you have 1 billion people in India and close to that Pakistan. People were starving over there. They eventually the wheat made its way over there, and they started growing it, and it started feeding people. So the Green Revolution, the key word here, green, it's not necessarily they were doing things organically or in a healthy manner. They just figured out ways to grow food, at a rapid rate, be able to feed the world for the most part. So a lot of things come into play in the Green Revolution, but it's not organic stuff. Don't confuse it for organic farming. So what did they do? Well, they came up with new crop varieties during the Green Revolution. They started using a lot of synthetic fertilizers, pesticides, crazy amounts of irrigation, and machinery. And the thing about the machinery, fossil-fueled machinery. All right. So now your food, the production of your food, all right, it used to be back in the day, they used to use animals and things of that nature. Now your food, just making your food, it has a carbon footprint because of the machinery that goes into producing it, right? So what happened to India? They started exporting for the first time. They were always importing food because they were starving. They had a lot of people to feed, and they couldn't get enough grains. If you go over to India, my wife's family is Indian. My wife is half Indian. She's been there a few times. I have not gone. I'd like to go. If you go there, if you go to India, you'll notice that hardly anybody eats meat. When you have that many people and you need to feed them, if they were eating meat, they have to feed the meat so much of what they grew that there wouldn't be food for everybody. So rather than growing food to feed the meat that they would eventually eat, they grew food and started feeding the people. So it's a vegetarian diet for the most part. And you'll see this in a lot of third world countries. When you go to these places, meat is very expensive. And that's because you're trying to feed a lot of people and you got to produce as much food as possible. All right. Big part of all this, though, once you start this green revolution took place, you started using fertilizers like crazy. Eutrophication started happening, hypoxia in nearby waters, chemical pesticides, polluted water. You started these pesticides, these fertilizers. You had a lot of water pollution. You had some of these aerosols in the air. You had air pollution. You had excessive erosion because of all this farming taking place. So you had a lot of problems as a result of the Green Revolution in this case. So what did they start doing in Green Revolution? They started growing monocultures. Everything is the same. Okay, everything's the same. And a lot of these plants, They're not just the same. A lot of them are clones, which means they're genetically identical. All right. So what happens? Well, when an insect or a pest or a disease shows up, if this whole field has pretty much predominantly the same genetic makeup, a disease, a pest, something shows up, and you will wipe out probably the entire harvest. That does not happen necessarily when you have organic farming. When you have organic farming, number one, you probably don't have a lot of monocultures. I've been to an organic farm, and it was polyculture like crazy. There was all kinds of different species of different fruits and vegetables that they were growing at this farm. Every little area was growing something different. If a disease showed up that affected, let's say, the strawberries, well, probably only affected the strawberries, and probably only affected some of the strawberries, because organic farming has more genetic diversity, which means that disease wouldn't have necessarily impacted an entire section of strawberries on an organic farm. It would have just possibly impacted a small set because of the genetic diversity within the population naturally. Genetically modified foods, their genetic diversity is very limited. They're pretty much, for the most part, a lot of them are clones, genetic duplicates of each other. But one thing you get from monocultures, if you don't get these diseases, efficiency increases, biodiversity decreases. Okay, so sustainable agriculture. We had a chapter previously on soil. Soil is a big part of this. If we can't maintain soil, we have too much soil erosion, agriculture will not be sustainable. So the whole goal is to grow food. What do you need to grow food and do it sustainably? Well, we had a chapter on soil. We have a chapter coming up on water, because without water, you cannot grow this food. We've talked about pollinators in many chapters, and we're talking about it some more in this chapter. We need genetic diversity to be sustainable because you got to be able to withstand the times. That is one of the positive effects of organic agriculture. It has more genetic diversity, which means if a disease shows up, if weather changes, if you have a weird season that year, unanticipated lack of rain or excessive rain, whatever happens, when you have genetic diversity, your crops can sustain it. They can sustain those changes. It doesn't happen with monocultures. All right. So to be sustainable, here's what we got to do. Here are the goals. I just said organic farming is a big one. Okay, big one. It's not monocultures. It's not. You have more genetic diversity. You can withstand the elements better. Technologies are a big part of this. Okay, because we got to get better at what we do. We got to feed more people. And people are saying nowadays, genetically modified crops might be the way we're going to be able to feed all these people. They're saying that sustainability may be reliant on genetically modified crops. Maybe. Okay? But just so you know, genetically modified crops would not be certified organic. So there's kind of a counter here. All right. So what is happening? Well, people, we like to eat meat, and especially in the United States, we are big meat eaters. In other countries, they're big meat eaters. Meat production has grown a lot. Seafood production has grown a lot. What have we done? We are no longer allowing these animals to just do their natural thing. We are trying to farm and produce and grow these animals for human consumption. So this has to do with some food security. All right. And by the way, like I said earlier, wealthier countries, this is where you're seeing more meat eaten than you are developing nations. You're not seeing as much meat. All right. All right. So the food we eat has environmental consequences. I find this section pretty fascinating, so people have a good idea of why it's better to eat vegetarian. All right. We've already talked about this in a previous chapter. Only 10% of the energy moves on to the next level, which means there's a huge loss of energy between levels. Where does that loss of energy go? Usually it's lost as heat when these organisms are metabolizing. Okay. So for example, you feed a cow grain, and by the way, we don't necessarily feed grain nowadays. Most of our cows in our country are fed corn. A lot of the corn grown in the United States goes into feeding cows. So cows' natural food would be grasses. All right. They would naturally be grass fed. They'd want to go walk around an area and eat grass. We are not feeding them grass. Most of the meat that we eat is being fed corn because it's high in calories, and we are subsidizing farmers. We're paying them money to grow corn so that we can feed all these cows. All right. So we are literally paying farmers to grow food that could go to humans, but it's not. It's going to feed cows. All right. So ideally, if you eat lower on a food chain, as low as possible, for example, like a vegetarian, it is much more efficient for the earth. It's better for the earth. All right. So let's talk about how this works. This chart here shows feed input, how much mass of feed goes into producing 1 kilogram of protein or edible food, you could say. All right. So edible meat, 1 kilogram. So to make a 1 kilogram hunk of beef or steak, for example, it would take 20 kilograms of feed to produce that. So you're talking a huge loss of energy to produce the next edible output. This 20 kilograms, instead of growing corn to feed the cows, we could have grown vegetables to feed humans. So we can literally feed 20 times more people if we were to feed them grains and vegetables instead of meat in this case. All right, showing you how much is lost. Beef is the biggest affecter of the environment. 7.3 kilograms of feed goes into making 1 kilogram of pork. 4.5 goes into making 1 kilogram of eggs. 2.8 to make 1 kilogram of chicken. 1.1 kilograms into making 1 kilogram of milk. So just so you know, chickens have been selectively bred, just so you know. I believe they get fully grown from birth to being basically, being chopped up and butchered and ready for your table. I believe it takes only 3 weeks. They haven't genetically modified the chicken. They've just selectively bred them in a way that they grow so fast that you're only talking about feeding these guys for about 3 weeks. And then they start producing. And then they're ready to go to the restaurant, your chicken sandwich or wherever it might be. Literally 3 weeks they get to fully grown. They grow so rapidly, it commonly snaps their legs because their legs don't get strong enough, fast enough to handle the weight of the chicken. All right, this is common. It's what people think it's inhumane. Well, what they do is they put them in these big pens. They feed them like crazy. They let them eat as much as they want, and they just grow and grow and grow and grow for 3 weeks, and then boom, they butcher them. They're on the table. They grow that quick, very, very quickly. So you'll notice out of all the meats, chickens generally fall lower on the impact realm compared to the other types of meats, and that's specifically because of how quickly they grow and how much they eat to get to those sizes. Yeah. Right. So let's talk about land required to make a kilogram of protein. Beef again. I mean, way more land is required. This would be if we allowed the beef to go out and roam and eat its range, go on a pasture and go eat the grasses. Pork, pretty bad for the environment. Here's milk, here's eggs, and here's chicken towards the bottom. Okay? And like I said, chicken grows very quickly, very rapidly. No one ever talks about that. It takes 3 weeks for them to reach full growth. Water. Look at this. Beef again. So eating beef is probably the worst meat you can eat for the planet. Milk comes in next. It says water, pork, chicken. Now eggs are down here. So chicken is towards the bottom almost every time. Greenhouse gas emissions. Now we talked about machinery being required to produce those. And the machinery, when it burns, it releases CO2, which is a gas that is a greenhouse gas that warms the earth. We will talk about that in a later chapter, but CO2 is a greenhouse gas emission. It's released when they burn the fuel to run the machinery. Beef is at the top of the list. Milk is there. Pork, eggs, and chicken. So chicken is towards the bottom in almost every category. If there's a meat you're going to eat that you should eat or it's better for the earth, you're probably looking at chicken. And most people don't consider eggs meat, but eggs become chicken, so they technically are meat. Feedlots. So this is what I was talking about. They got all these chickens. They're factory farms, they might call them. What they're doing is you put a bunch of them in these pens, and you let them, and you feed them, and you give them water, and you give them food, and you let them just grow. It takes about 3 weeks, like I said earlier. Sometimes you may see chickens. They may be called free-range chickens. Apparently, it's kind of a myth. In the pen, they may open an area so the chickens can technically leave the pen and walk around and get some exercise. But generally, the chickens do not leave the pens and go into that area that they are now classified as free range. What they do is they don't leave because it's usually hot in these places, and you're talking middle of summer, and these chickens don't want to go outside where it's 100 degrees and humid, so they stay inside of these pens generally. So when you're eating free range chicken, it's not much different than the chicken in these pens. For it to be free range, like I said, they just have to open up a small little door somewhere where the chickens are allowed to go outside if they desire. If they don't desire to go outside, well, then they didn't desire to go outside. And so that's what makes your chicken classified as free range. It's not really much different, right? A lot of factory farms, one of their impacts is that they use a lot of a lot of hormones are used in some cases to make them grow faster. All right. I don't know if chickens are allowed to use hormones anymore. So you may notice hormone-free chicken. And that doesn't mean they're doing something good. I believe they're not supposed to be using it anymore. So I believe most chicken is hormone-free nowadays. That's not saying the cows and the milk isn't hormone-free, but I believe that's the case with chicken. Antibiotics, though, they use them a lot because bacterial infections break out like crazy and wipe them all out. So they use a lot of antibiotics. So a lot of antibiotics. Ideally, if you want to get good chicken, you want to get an antibiotic. I already mentioned hormones aren't there, but it'll be labeled antibiotic and hormone free. They call it free range, but I just told you the chickens generally don't leave the pens because it's too warm outside. And they do the same thing with cows. They stuff them all in these feedlots. All right? Here are cows. So what happens in these feedlots? What do they do? Well, number one, you have a lot of concentrated waste. All right? If flooding takes place, a lot of rain takes place, this concentrated waste can flood nearby areas. Every now and then you'll hear about, for example, in the United States, we've had recalls on lettuce. All right? And we're like, well, what happened was E. coli got into the lettuce. And people were getting poisoned all over the place because of the E. coli. Well, they never talked about where that E. coli comes sometimes. But a lot of that E. coli comes from flooding in regions that have feedlots. And so I believe the most recent situation in the United States where they had a recall on lettuce, they never talked about where the E. coli came from, and I believe it came from some pork, some pig farms nearby, and their waste, concentrated waste, somehow contaminated the farmland nearby, and they still sold it to the public, and people were getting poisoned by the E. coli that came from the fecal matter. Fecal matter is also rich in nitrogen and phosphorus and all this stuff. And what does that lead to? These wastes lead to eutrophication. Big time pathogens and bacteria and viruses are spread around in these close, high density areas. So disease spreads quick in these high density areas. And I already mentioned to you, hormones and antibiotics are used to prevent illness within their grouping, and hormones to help speed up the rate at which they produce milk or the rate at which they grow. Okay? They also give them different medicines and drugs, and it's all comes out their waste and ends up polluting nearby areas. The reason it pollutes areas is you're talking about concentrated waste all in one area. I mean, this area is full of waste. And then you have a rain, and this area floods, and everywhere nearby is going to have a catastrophe, basically. Aquaculture, well, this is feedlots, but they're not feedlots. They're in the water. They're pens. They create pens in the water, and within these pens, they grow food. All right. Ideally, me personally, I prefer wild caught fish. Wild caught fish means they caught it in the ocean, and that fish has usually the right minerals and nutrients because it's eating its natural diet. Okay. Aquaculture, farm fish or farm salmon or farm tilapia, these are real common. They generally put all these fish in a pen in the ocean or somewhere. And they could be freshwater fish too, depends. And they can do them inland if they want to. And they grow all these fish in these high density areas. All right. So aquaculture is a big deal because a lot of the world needs protein and a lot of the world eats fish. We eat a lot of fish here in San Diego, but in comparison to other cities in the United States, maybe more, maybe a lot more. But specifically, certain cultures eat a lot more fish. So this is pretty much fish farming. A friend of mine is an underwater welder. He has a very crazy job. I believe he told me recently that they approved some ocean pens off the coast of San Diego for aquaculture. He didn't tell me what kind of fish. He just welds and makes the pens. He doesn't even know exactly what they're going to be growing there, but they're going to be doing this off the coast of San Diego is what I'm hearing. I'm not sure where exactly off the coast of San Diego, but they got approved on the plans to do this. Aquaculture. So what's the problem with it, or what are the good things? Well, it increases food supply big time, and it's a good source of protein is what it does. All right, and it makes fish cheaper than they would be if you were to eat only wild caught fish. All right, because we're growing the fish, the whole goal is to reduce overfishing, and I do not know if that's taking place. I believe overfishing is still taking place with wild fish or things that grow in the wild. Overfishing of wild fish is taking place with or without all these aquaculture taking place. All right. What happens when it's on a large scale? Well, they use antibiotics again. Same thing. You have a high density, right? So you have a density dependent factor of disease. They're close to each other, so they have to use a medic. They usually put this in their feed. It destroys coastal ecosystems. Well, what does it do? Well, once again, you have a massive amount of waste produced in an area. So those ecosystems are now dealing with wastes that are throwing off the balance of their environment. Disease or an invasive species. So we already said, if these fish, for example, like get out, they can be invasive within their populations, because we may be introducing a fish and growing it in an ocean pen, and it gets out. Now it can become potentially invasive with the natives. It can spread disease to the natives. All right. So that's one of the major problems with this aquaculture. Same thing. You're talking about a high density. You're talking about habitat problems due to the result of too much waste produced by them. Not to mention, I don't know how healthy aquaculture is, because they don't necessarily feed the fish its natural food that would intended to be eaten. I believe salmon, they feed them dye in some cases to make their meat that salmon or that orangey pink color. So because if they're not eating their natural diet, their meat will not take on that actual color. All right. I believe they feed tilapia, which is a very common one. I believe they feed tilapia sewage, actual human sewage, because tilapia will eat just about anything. And I've seen videos of trucks dumping human fecal sewage into the water so that the tilapia that was farmed could eat it. This is not happening in all fish that is farmed, but some fish is farmed in a more sustainable way, where they'll use pens, and they may have them inland pens where they create for example, a body of water inland, and they're circulating the water much better, so you don't have a buildup of all this waste. So remember, you're going to be eating a fish that was in a pen, and they start beginning to eat their own waste products as a result of that. So it's not going to be you're not going to be eating if you have the right pens and the right circulation, then it'll remove some of those toxins and those waste products that are produced. But that's not always the case. A lot of times it's just done in like a cage in the ocean, and then all the waste products get trapped there. I believe salmon. Well, not I believe. I know they now have genetically modified salmon. It grows extremely fast and larger. So that is one of the salmons that they're growing or they're harvesting in these pens. So crop diversity. Well, this is a big deal. We have gone to monocultures where now we don't have a lot of crop diversity around the planet. We have very little crop diversity. Land races. These are the natives. These are the original crops that we eventually selectively bred and developed these monocultures for the most part from. So land races are very important because they're the native crops, what corn should look like, what a lot of potatoes should look like. But we have bred them in a way, we've selectively bred them in a way so that they grow and look a certain way, and they always look a certain way. But there's many different varieties of corn and potatoes. Well, what's important about these land races? Well, if we have an issue, a disease breaks out and wipes out a lot of these monocultures, these commercial crops, then now we can go back and we can have genetic diversity from our land races, and we can use that to probably, hopefully, select and grow more crops that can now sustain these new changes in the environment. So the whole goal for natural selection is you need variation to survive the changes. Land races allow us to preserve that variation. Seed banks, well, they're saving seeds. They're seed banks, and this seed bank is a picture of one in the Arctic Norway region. What do they have there? Millions of seeds around from all over the world are being stored there, in case there's ever a doomsday situation where we lose some of our important crops, a disease breaks out, something happens. We can hopefully go to one of these vaults, so to speak, and or these seed banks, and we can start over again. All right. Honeybees, we've talked about them a lot. What are the major sources of their decline? Well, we know that they help us produce food. And this is just some of the foods that we rely on honeybees for. This is just some. The list goes on and on and on and on. What are the big sources of their decline? Well, I've mentioned before insecticides, and later in this lecture I'll tell you specifically the insecticides that are doing the most damage. Okay, so pesticides or insecticides. Parasites and pathogens are killing them. And where are they coming from? Well, humans are traveling the world and bringing invasives with them in different places. Another one, a lot of their habitat flowers are being destroyed and people are growing food. We're growing crops instead of their native plants that they prefer. So a lot of habitat alteration, habitat loss is taking place too. And colony collapse disorder, this is the term that they're using to talk about what is destroying about a third of all the honeybees each year. You probably notice dead bees lying on the ground near your house outside and just laying there. They're not smashed. They probably came across a pesticide of some sort as they in a neighborhood, in one of your neighbor's gardens or in one of your neighbor's flowers, and then they picked up this pesticide and then they ended up dying and ended up dying near your house somewhere. That's real common. So the term they use for that is colony collapse disorder, basically. And the methods I just spoke of previously are what's causing it. What can people do? They can, like for example, if this is a field that a farmer is growing food in, they can plant buffer zones of native flowers. So these bees are not going to be losing all of their habitat. You can still preserve some of their natural habitat that they prefer. We'll stop there.